Okay, so before the break, this is where we started our searching and sorting unit. We set it up by creating a few variables that we're going to use all through the example. So we have a size variable that will control the size of the array we're going to use. We have an array that we set to null to start. We have an item, that's the thing we're going to look for, and the location is where it will find it. So right now we're just setting all these things to just null values and just 0 values just to get ready. And then we used some methods and classes to assign them values. So the item comes from a class called numberTools, and we generate a random integer. So we basically say, here's a random number to search for. We generate an array from the numberTools class as well by creating a random array. So the numberTools class is just a little class that helps so that we don't have to put a whole bunch of code right in our example. And here you can see in the numberTools class, we made a random integer method. We've done that before. And we made a random array method that calls the random integer method. That just generates the array full of random integers. And then what we did after that is we showed the array, and we did that through a class called display. Again, just to optimize our code a little bit, we made a little class called display, and it basically has two methods: show, that just outputs what the array looks like, and show results, which will be something will be useful for searching. So when we do searches, it'll say item was found at location whatever, or if it returns -1, we'll say that the item was not found. So that's done, so that it just optimizes our code. So we say display the array, then we say search for the item in the array, and then just show the results. Now, what we did then was we put our search into a class called searchTools, and we used the first search algorithm, the linear search. Okay? So this is where we left off. Where I want to go today is our first sorting algorithm. Okay? So what we had right here was our linear search algorithm. Now what I want to do is our first sort, and it's called the bubble sort. So what I want to do is I'm going to repeat some of this code. I'm going to re-randomize the array. So I'll just do that. So that will create the array again. So it's created again. Okay? And then I will show the array again. Okay? So I create the array, I show the array, and then I'm going to show it again, but in the middle, between the two displays of the array, I'm going to do a sort. Okay? I'm going to do a bubble sort. And I'm going to do that using a class called sortTools.bubbleSort. And I'm going to pass it the array to sort. Okay? Now we don't have that method yet. Okay? So we don't have a method called bubble sort. We don't have a class called sortTools. So we're going to build both of those. But another nice thing that's going to happen, I hope, when this is done, is it's going to show that the array is now in order, like it's sorted. Okay? So I think I'm going to just quickly overload the show method as well, so that I can tell the difference between the two arrays, a regular array and a sorted array, by just putting the word sorted in front of this. Okay, so I'm going to have to make a couple changes to my code to fix that. Okay? So here again is what the code is we're going to start with today, is these 4 lines of code right here. Okay? So we recreate the array. That'll just re-randomize it. We show that array so the user can see what it looks like. Then we will sort the array and then show it after it's been sorted. So the first thing I want to fix is I want to go to the display class and overload this show method. This is going to be very, very easy. So I'm going to use the light bulb to do this, or you could just go directly to the display class and write in the second version of the method called show. Okay? Okay? So really, all I'm going to do is the same thing I did before. Basically the same code. So I'm just going to copy this code, put it here, So it's almost identical. Okay, so all I did was I copied all the code from show into this version of show. So it's the same basic method. And I'm going to switch the name of this parameter right here to type. And I'm just going to do that. So let me highlight again the changes I made. I made a change right here by putting in the word type there instead of the word sorted. And I changed this line right here, right there. Those are the changes I made. Other than that, the method stays the same. Now, I probably could modify both of those methods to make things a little more optimal, but I think this will work for now. This will be fine, okay? Okay, anyone not got that? Very simple change. Okay, don't try and run your code yet because we still got a major error. If you want to run it, you could comment this line out for now. And then if you tried to, it should still run that way. Okay, so again, you can see here now the only difference is this one will say sorted, whereas this one says array, right? This one says array and this one says sorted. That's the only real difference. Okay, and what we're going to see hopefully is that this will now be in order when it runs, when we get that part working. Okay, so now let's go back to here. And now let's build this class called sorttools. So you can use the light bulb to do this. Create a class called sorttools. And it should automatically just generate the class for you, which is nice. Then I'm going to go back again, and now I'm going to use the light bulb to generate the method called BubbleSort. And it should generate the method for me as well. Okay, so very handy. You can certainly code all that yourself if you want. But it's easier if you use the light bulb. Now, what we're doing is we're passing an array to this method. We're passing to the method within the class. Now, what's going to happen is the method is going to switch things around inside the array. It's going to shuffle positions around. So when this method is done, the array will be changed. And that's because arrays, when they're passed to methods, are passed as the entire array, as a reference to the array. Not a copy of the array, but the actual array is passed to the method. So anything that the method does to the array will be reflected after the call of the method is done. Okay, so now I just want to real quick review what this method, what this bubble sort does. We talked about this briefly before spring break. So I'm just going to review that with you guys real quick. Oop, I guess I got to put this in there for that to work. Okay. So what the bubble sort does, okay, is it moves through the list, essentially bubbling items to their correct position. Okay? It does this by swapping items. Okay? It compares one to the next, and if they're in the correct order, it leaves them alone, and if they're not in the correct order, it swaps them. Okay? The result of this is it will bubble things to its position. So I created a real quick little animation for this, just to sort of demonstrate. So here's an array. It checks the first two. They're not in the correct order, so it swaps them. It switches them around. So now the 4 and the 17 are swapped positions. Then it goes to the next two items. So now the next two will be 17 and 8. So it looks at those two, and those aren't in the same position, the right position. So it'll swap those two. Then it'll go to the next two, which is 17 and 24. Now 17 and 24 are in the correct position. 17 and 24 do not need to be swapped, so they're left alone. But then when it goes to the next two, 24 and 1, those will get swapped. Okay, so they'll get switched around. Okay, now it has now gone through the entire array. Okay, it's looked at each pair as it went through. It's not sorted yet, but it's closer to being sorted. So what it's going to do is it's now going to repeat that process. It's going to go through the array again and continue to swap items. How many times do you think it would need to go through the array to do this? What would be like the worst case scenario?
5.
That's right. 5 is right. In other words, the amount of items in the list would be the worst case scenario, right? So if it was a list of 500, it might have to go through it 500 times, right? So that's right, okay? And et cetera. So I've got more sort of animations that sort of demonstrate this, but you get the idea, I think, right? Okay, so let me get through that. Okay, forget that. Let's code this. Okay, so in order to travel through the array, we need a for loop. Okay, so remember, you can quickly type in a for loop, if you want, by just typing FOR and then hitting tab. Now the array does not, or the loop does not go from 0 to 10. It goes from 0 to array.length. Okay, because we don't know how many items are in this array at this point. Okay, so that will first of all do what we asked, to travel through the array. But then we're going to need to do that multiple times. So what we're going to need here is a second for loop that goes through array.length. Now, if you use some of NetBeans auto features, it will name these two variables I and j. It is very non-creative about naming these variables. That's fine. I'm okay with those. Those are fine names for variables. I is traditionally used in loops because it stands for iteration or index. Either of those is fine as it loops through the array. J is picked because it's the next letter after I. That's really the only reason they picked J. So now, inside the loop, what we're going to do is we're going to compare by using our if statement. If the array at spot j is greater than what's in the array at spot j plus 1, in other words, the next spot over, we will swap them, which I'll write the code in a minute. We will swap those two values. And that's it. Really, that's the whole algorithm. But there's a couple potential errors here. Okay? So let me draw out what would be happening here by just drawing a little array right in front of us here. Spot 0, 1, 2, 3, 4. Can I have a random number, please? Another one. Make it -6. Another one. Another one. 28. And we'll make that one 401. Okay, so there's a random array. Okay, so let's think about how this is going to work. It creates a variable called I, sets it to 0, creates a variable called j, sets it to 0. Right? That's what the two loops do. Now we're inside the inner loop. We're looping just with j. So it looks in the array at spot 0 and spot 0 plus 1. So it compares these two values. If this one is greater than that one, which it is, it would, when we write the code, swap them. So in other words, this will now be -6, and this will be 10. So far, so good. Then it would stay within the inner for loop here. So in other words, now j would go to 1. And now it would compare spot 1 with spot 1 plus 1, or in other words, spot 2. These are not in the correct order. So it would swap them. This would become -17, and this would become 10. And then j would go to spot 2. Okay? It would compare spot 2 to spot 2 plus 1. These are in the correct order, so it would leave them alone. Okay? Then it would go to spot 3, right? So you can see here, it keeps going, so it goes to spot 3, and it would compare this one with this one, spot 3 and 3 plus 1. And those would get swapped, 28, 401. But here's where the error hits. It would now, because I'm looping to array.length, less than length, the length is 5. What's less than 5? Well, 4 is less than 5, so it would go to spot 4, which seems to make sense. There is a spot 4. Here's where the error hits when it compares spot 4 to spot 4 plus 1. There is no spot 4 plus 1. So this will right away cause an error. So let's fix that. That's an easy fix. We'll go to 1 less than the end of the array. So in other words, we'll go to this minus 1. Whoops. So that should fix that. Now, let's perform the swap. Now, every year I use this demo to try and identify the swap. Okay, so I'm going to use this cup right here, this beautiful trophy cup, and this coffee cup. Okay, here's what I want to do. I'm going to put a Kleenex, and let's imagine it's full of Kleenexes, in this cup, and this one obviously is full of pens. What I want to do is I want to put the pens in there, and I want to put the Kleenex in there. How would you do it? Maybe I should put it this way. Forget the pens and the Kleenex. Let's say, let's use a more liquidy example. Imagine that this cup is full of coffee, and this one is full of Pepsi or Coke. How can I get the Coke in here, and I can get the coffee in there? Anyone got an idea? 2 other containers. Now what was suggested to me last semester was just drink the coffee, pour the Coke in there, and then spit the coffee into there. But you're doing the same thing, okay? Usually I also have some smart aleck kid who will say, well, you can actually do this, Mr. Walks. Just throw the Coke up in the air, quickly switch them, and then they'll catch both of them in the same thing. Doesn't quite work. But it's also something you can think about in math. Like, what if I did this in math? What if I said x equals 5, y equals 7? If I wanted to swap those, can I just do this? X equals y, y equals x. Does that work? What's inside of y right now after the end of that run? If that was actual code right here. Think about it. This is x, this is y. I just said x is 5, y is 7. The next line says x equals y. So this becomes 7. And then what does the next line say? It says y equals x. And what's x? 7. Now they're both 7. In order to swap 2 things, you need an intermediate variable. You need something to hold on to something in the meantime. So that's exactly what we're going to do with this little code right here. So here's what we're going to do. We're going to make a variable, a little integer to hold on to it. Let's just call it, I don't know, swap equals array spot j. So that's holding on to what's in spot j right now. So now I can replace what's in spot j. Array spot j equals array spot j plus 1. Then array spot j plus 1 equals what? It equals swap. That's right. It equals our temporary variable. So that performs a traditional swap algorithm right there, to swap the contents of an array from one spot to the next. And if that works, this should be a working algorithm. Let's try it. I'm going to run the code. So here's the original array, 3, -10, 4, -2, blah, blah, blah. And look, here's the sorted array, -10, -9, -8, -5, 4, 3, all the way up to +15. It worked. It sorted the array. Now, it actually did it pretty fast, too. So I'm going to jump back to this one, and I'm going to push this computer. Let me try 150 items. Done. Took 0 seconds. How about 1,500 items? Done. 0 seconds. How about 15,000 items? Oh, there was the search. By the way, it's performing a search as well. 6 seconds. Took 6 seconds. But now you can see what's happened. We just generated 15,000 random numbers and then sorted them. Impressive. That's some impressive code right there, I think, that you guys should be impressed by. Okay? Did anyone not catch that? Any of that code missing for anybody? This is the basic bubble sort algorithm. It is very basic and not efficient, believe it or not. It works. It will sort an array, but not in the best of ways. It's not the most efficient of ways to do it. Okay? So we're going to modify it slightly. We're going to make things a little more efficient. Okay. Just one sec. Okay. So that's right. Once it's in order, it doesn't stop. So that's the first inefficiency. There's a second one. Okay? The second inefficiency is this. Let me just show you. I'll put a pretty small array. Okay, so let's say this was the array. Watch what happens with 400 right now. Okay? 400 would be swapped to here. Then it would be -6 here, 400 there. Then 400 would go to there. So the 400 would be there, the 5 would be there, right? And the 400 would be there. Then it would compare it, and it would go to there. So the 400 would wind up here, the 2 would be there. What happened was the 400 bubbled to its correct location. The 400 is now there. The next time it goes through this loop, okay, it'll compare this to this, and they'll be fine. It'll compare this to this, and it'll swap them. The 2 goes there, and the 5 goes there. But here's the question. Does it need to compare these two? The answer is no. Once 400 gets to there, it's in its correct spot. And now that 5 has got to here, it's in its correct spot. The next time I go through this loop, I will not have to compare those two. So in other words, every time it loops, it'll put one of its items in the correct spot no matter what, so that the next time we loop through, we don't have to do that. So here's how we're going to optimize our code. This will make it a little more efficient. Okay? What we're going to do is we're going to modify that first loop up here. And instead of looping forwards, we're going to loop backwards. In other words, we're going to start I at array.length -1. Start I at the end of the array. And keep looping while it's not this, but greater than or equal to 0. So this will now be a loop that goes backwards. So instead of going I++, we go I minus. Now, what this will do is it'll start at the end of the array and move towards the beginning. So I change this part right here. Notice the -1. I change this right here. Notice it says greater than or equal to 0. That's because there is going to be a spot 0 in an array. And I change this part to be minus, because we're now going backwards. Now that really doesn't seem to make a difference at this point. It's still the same number of loops, right? Still the number of iterations. But the big change happens now on the inner loop. On the inner loop, now I change this to I. Okay? That makes a huge efficiency difference, because now with I there, it will loop up to whatever that value is, and that value will change every time it goes through the loop. So it reduces the number of comparisons it has to make. So that made the first correction. The second one is the one that Stephen pointed out. What happens if it's already sorted? Okay? Well, let's take care of that. We're going to take care of that by creating a Boolean variable called sorted. And we're going to assume that it's true, that the array is in fact sorted. We're going to set it to be true. We're going to assume that the array is sorted. Okay? We're also going to set it to true after the first loop. So this is going to flag that we're going to assume the thing is true before we head into this inner loop, right? So we're going to go, remember, it's this inner loop that actually goes through and does the swapping. This outer loop just counts how many times to do it. So we'll assume, you know what, I'm going to assume that this thing is sorted. But if at any point I perform a swap, if I perform a swap, then it's not sorted. I had to swap something around. So if it's not sorted, in other words, if I swap something, I got to keep going. So at this point, I set sorted to false. Notice how I do that inside the if statement. Inside the if statement, if I make a swap, I better go through the array again. Now, one more line. After this for loop here, after this for loop is done, before I go back and try and do it again, I check, well, if it's sorted, I'm done. So at this point, I can just return. That's a way you can break out of a loop, even though I'm still inside this outer for loop. So even though I'm inside this for loop out here, if it's sorted, I can hit the return command, which breaks out of the method completely, including breaking out of the loop. So this was the inner for loop, right here. So in other words, I assume that it's sorted, but if at any point during this inner for loop it performs a swap, I say, oh, no, it's not sorted. So then when it comes to here, it won't return. It'll go back and perform the operation again. This has now fixed those two inefficiencies. This bubble sort is now a more efficient bubble sort. It will still work. You can see there. Let's see if it actually makes a difference. I'm going to set that back up to 15,000 again. Who remembered how many seconds it took the first time I run this? No, at 15,000, 6. So in theory, this should be a little more efficient now, okay? Seven, less efficient. Now, it could be the numbers that it ran. I'll try it one more time. But in theory, it actually is more efficient. Now, I didn't prove that to you guys at all, did I? 5 seconds. There, it was 1 second more efficient that time, okay? Okay, but the efficiency of algorithms is actually an entire realm of computer science that we're just scratching the surface on. Just getting it done is like, I heard a great quote, did I tell you guys at the conference? So I'll apply it this way. Writing code to just get it done is like using duct tape. It can fix anything, but probably shouldn't be used for everything, right? You can't just write code always to just get it working. Although I understand that. I understand that sometimes that's the case. But sometimes you have to think deeper what's more efficient about this code. Okay, the bubble sort is now complete. But now we're going to take a look at something else, okay? We're now going to look at a second type of sort, okay? So we're going to go back to there. Bubble sort's done. And now we're going to look at something called the selection sort. It's a different algorithm. So it's basically going to have the same 4 lines of code. So I'm going to put them in there. The only difference is right here. I'm going to write something called selection sort. Okay, so we're going to put that method into the sort tools class. And again, the reason I'm putting them into classes is that so you guys can break your logic up. If you want to use something like this for your final project, you've got the code ready to go. And it's not buried within some large example. You've got the code in a specific place. It's in a class called sort tools, which is easier to find. So now we're going to recreate this scenario. We're going to just show the array. We're going to sort it, and then we're going to display the sorted array, okay? But this time we're going to use a different algorithm to do it called selection sort, okay? So let's do that. Let's use the light bulb, go to the sort tools, and now let's take a look at selection sort. Now, selection sort is actually an algorithm that you came up with more naturally. This is the more natural way to sort things. We don't normally think of sorting things by switching positions and doing swaps. So this is actually a more natural algorithm, but it's, believe it or not, harder to code than the other one. So again, the idea is, what you do with this algorithm is the way you sort things normally. You look for the lowest item, you take it out, and you start putting it into a new list, removing it from the original list. And you continue this until all the items from the original list are gone and the new list is created. So here's the example. This is the way we sort naturally. We look through this list and we find, for example, the smallest item. So we look through it, we go, what's the smallest item? Okay, it's that one. So I'll move that one to the new list. But think for a minute how that worked. In order to find the smallest item in a list, I had to look through the whole list. It's possible that the lowest item was at the very end. I don't know until I've looked through the whole list. Now that I've copied it over to the new list, it can no longer remain here. Because otherwise, if I try and do this again, I'm going to find it the second time. So I have to remove it from the original list. But now I repeat the process. I look through, find the lowest item, copy it over, and I can continue this process, looking and copying, until there's nothing left in the original list. Once there's nothing left, I'm left with now a sorted new list. Okay? So this is how we're going to do it, but to do this, we have to kind of make a few adjustments. How do I delete something from an array? How do I make a new list? How do I know all these things? So we're going to do that. We're going to incorporate that into our logic. This is the pseudocode on the selection sort right here. The pseudocode is allocate a duplicate array to store the value. So I create a duplicate array. Loop, while there's still values in the original array, find the lowest in the original and remove it, add the lowest to the duplicate at the first available spot, and then copy the duplicate back onto the original. Wow, let's do this. Okay, so I'm going to make some assumptions with this code that we're going to be using some methods. We'll make the methods later. So the first thing is we have to make a duplicate array. I'm just going to call it duplicate. Equals, and to do that, how do I make a duplicate? Okay, well, I will make a method called create empty duplicate. And I'm going to pass it the array because that's what I'm making a duplicate of. I'm making an empty duplicate. So in other words, it's not a copy of the array because I want it to be the same size as the array but filled up with empties, whatever that means. We have to figure out what that means. Now I'll hit a loop. While not empty, while what's not empty? Well, while the array is not empty. Okay, and again, we'll make that method. The lowest value, so I'll make a variable called lowest, equals find lowest. But I'm going to try and do two things at once. I'm going to say find the lowest and remove from the array. So I'm going to find the lowest thing in the array and remove it. And then I'm going to add to the back the lowest value. I'm going to add it to the back of my duplicate. Again, these are all methods we're going to build. Just basically doing the pseudocode here. And then finally, when the loop is done, I will copy the duplicates onto the original array. And so in theory, then the array will be sorted because it'll become the duplicate. So this is the pseudocode behind this. This is, again, a way you can program by thinking methodologically of what methods will perform the operations that I want them to perform. And now I'm going to go in and take care of all these methods. So I've got to write 1, 2, 3, 4, 5 methods right now. These 5 methods will all be private methods. They'll be just inside the class, utility methods that will help get this job done. I won't need them necessarily outside the class because this class is supposed to focus just on sorting. It's not supposed to do stuff like removing from arrays. So these will be little private methods. Okay? Anyone not get those? So let's start with the first one. Create empty duplicate. I'm going to use the light bulb and create it. Okay? And then I'm going to go and use the light bulb on the next one, not empty. And then the light bulb on the next one, find lowest and remove. And then add to back. And then finally copy. Okay? So in theory now, although all these methods are empty, they will perform the operation selection sort. So now selection sort in theory is done. But we got to fill in the blanks of these things that were left blank at this point. Okay, now they're not that bad, most of these methods. They're not that long. Okay? So let's start with create empty duplicate. To do this one, I make an int array that I'm going to call duplicate. And it's equal to a new int, and the size of it is array.length. So it matches the length of the original array. At the end of this method, I will return the duplicate. Okay? So that looks pretty good. That would actually do it, but duplicate will now be filled up with zeros. Right? When you create an array, it's going to be filled with zeros. And the problem with 0 is it could be a valid number. I need a number that's really uncommon. And 0 is way too common. So I'm going to have to kind of cheat a little bit. Now, if this wasn't a primitive data type, if this wasn't integers, if this was something more complicated like strings or a class that you made, an array of your classes, you could use the value null. That's a perfect thing to represent an empty spot. But because it's type integer, you can't use null. Null is not used with primitive data types. So I need an extremely rare integer. Can you name such an integer? Of course you can, because they're all, if it was extremely rare, you wouldn't be able to think of it. But I can think of it. It's built into the class called integer. Notice the capital I. And there are two really rare ones, the maximum value and the minimum value. These are two extremely rare. They're as basically as big or as small as the value of an integer can hold. So for example, for max value, it's 2 to the power of 31 minus 1. That's a pretty big number. And for min value, it's negative 2 to the power of 31. Again, notice there's one difference there, but we talked about that back in grade 10. Extremely rare. That's going to represent, for me, an empty spot. So what I want to do is fill up my array with that. So I'm going to use a for loop. I'm going to loop through duplicate.length. And I'm going to say into duplicate at spot I, you're equal to integer dot min value. So I'm going to fill it up with extremely rare values. That's how I create an empty duplicate for me. Okay, and it's a bit of a trick. It's not the most efficient code. I'm going to show you a more efficient way to do this later. But for now, that should get the job done. That should fill it up with temporary integer values. Okay, the next method we're going to work on is this one called not empty. So what not empty is going to do is it's going to look through the array to see if there's anything still in it. So the way not empty works is it again uses a for loop. Most of these will use for loops. And it'll loop not to 10, but to array.length. Okay? What it will check is if the array at spot I, okay, is not equal to integer dot min value, I will return true. So in other words, if there's something in that array that's not one of those min values, then there's something still in that array. If it's full of min values, then it's essentially all empty. So at the very end, at the end of this for loop, after the end of it, at that point, I can return false. Okay? So I have two return statements, one at the inside the loop and one at the end after the loop to determine whether or not this array is empty or not. It's kind of a weird logic. The not empty is kind of a strange way to write it. So some of you might have to just take my word on this one. Okay. This is the next method is called find lowest and remove. This is actually the longest of the methods so far. But am I going too quickly? Has anyone not got that yet? Okay. Taking a sip of coffee and then we'll go to the next one. Okay, find lowest and remove. This is essentially a search to find the lowest value. So I'm going to start by making something called lowest. And I'm going to make it equal to integer dot min value. Sorry, max value. So I'm going to start the lowest off at an extremely high number. I'm going to create a variable called location equal to -1. That's where I'm going to find it. I'm going to start my for loop going. I'm going to go through to the array.length. And my caps lock is on. Okay. And now I'm going to determine if the array at spot I is less than the lowest, but I have to also have one other condition with this. And, remember the and symbol, and array spot I. And I'm going to move this down a line just so I don't run out of space there. And array.I is not equal to integer.min value. Because that one is going to be an extremely small number, but it's one we want to ignore. We want to ignore that because that's representing a deleted value. So that min value represents something that's deleted, so that's why we're skipping it with our if statement. But if that's true, then the lowest number equals array spot I. That's now the lowest number. And the location is equal to I. That's the location I found it at. Whoops. Okay, so that loop will go through the array looking for the lowest value, and it'll track its location as it goes through the array. At the end, after the loop is done, I will go into the array at spot location, and I will delete it by setting it to integer dot min value. Remember, that represents a deleted spot. There's actually a name for this, which I'm going to go over in a minute. And then the last thing I do is I return the lowest. I have to return that. What we're doing here is we're not really deleting the spots. We're just setting them to that extremely small number. This process, you guys are going to love this as teenagers. This process is known as lazy deletion. Because you're not actually deleting it from the array. We're not actually resizing the array. We're just tracking it and marking it as deleted by setting it to an extremely rare value. This is called lazy deletion, and it's not the most efficient code, but it works, just like duct tape. Okay. I'm going to try and beat the buzzer here, kids. Add to back. The rest of the methods aren't as long. That was the longest one, find lowest and remove. Add to back. What this method's going to do is it's going to put that variable lowest at the back of this array. Well, and by back I mean the first spot that's not empty. So here's how it works. I fire up a for loop again, going through duplicate.length. This time it's called duplicate because that's the name of the array we passed it. We passed it duplicate. Okay? I say if duplicate spot I equals integer dot min value. That's an empty spot. That's the empty spot I can use. So if I just found an empty spot, duplicate spot I equals the lowest. I put it right there. That's where I can stick it, right there. And at that point, I can just return. I'm done. I don't need to keep looping. I can just get out of there at this point. I'm done. So that's how I'm going to add it to the back of that array. It's really adding it to the first available spot that I can use. And then finally, we have to make a copy. We have to copy the duplicate onto the array. Now I'm going to rename these two parameters right here. I'm going to rename duplicate source, and I'm going to rename array target. That'll make a little more sense. I'm copying the source onto the target. And all I do for that is use a for loop, going through source.length, and I say target spot I equals source spot I. That's it. That's how I copy it. And you'll actually get a light bulb here, because built into Java is a way to already copy one array onto another. And if you want, you could use that method. But I just think it's useful to write your own method for that. But hopefully now, with all that code in place, I'm going to run the test on the selection sort algorithm, and it hopefully should work. Okay? Oh, am I still at that huge number? 15,000, I guess I am. Okay? So here you can see it just built, and there it did. 9 seconds. It did the second sort, the selection sort algorithm. Okay? So just to distinguish them, I'm going to put the word selection sort here, and I'm going to put the word bubble sorted here, so that, again, you can kind of see what's going on there. Okay, we're going to stop there for today.